Hello, this will be a demonstration of proposition 3 from book 6 of Euclid's Elements, which says that if an angle of a triangle be bisected, and if the straight line bisecting the angle cut the base, the segments of the base are to one another as the corresponding remaining sides, and also the converse, and if the base be cut such that the segments are to one another as their corresponding sides, the straight line from the point of section to the vertex bisects the angle. What we're given is the triangle ABC. And this is another proposition where there are two possible givens. Either we have the straight line AD bisecting the angle BAC, from which we're going to prove that BD is to DC, just as BA is to AC. Or the converse case, we have the base BC cut at the point D, such that BD is to DC, just as BA is to AC. And under that given, what we're going to prove is that the straight line DA bisects the angle BAC. We're going to begin with the first case, where the angle BAC is bisected by AD. And if this be so, we're going to draw through the point C the straight line CE parallel to AD. And we know that the straight line BA and CE, if produced far enough out, will meet. How we know this is that this angle plus this angle is going to be less than two right angles. The sum of the angle ABD and ADB is going to be less than two right angles. That's proposition 117. That if you add any two angles of a triangle, they are going to be less than two right angles. So angle ABD plus angle ADB is less than two right angles. And the angle ECD is equal to the angle ADB by parallel lines. That's proposition 129. So because EC is parallel to AD, the corresponding angles ECD and ADB are going to be equal to each other, which means that the angle ABD plus the angle ECD is also going to be less than two right angles, which means by postulate 5, if we produce these lines far enough out in that direction, they're going to meet. So we're going to produce BA to the point E. Very long way of describing just producing a straight line continuously in a straight line. That's just postulate 2. Now, we know that AD is parallel to CE, which means that the angle ACE is going to be equal to the angle CAD. This is by proposition 129. So CE is parallel to AD, which means that the alternate angles are going to be equal to each other, which means that the angle DAC is going to be equal to the alternate angle ACE. Now we also know that the angle DAC equals the angle BAD because of our given. We know that the angle BAC is bisected by the straight line AD, and so we know that the angle BAD is going to be equal to the angle DAC, which means by common notion 1, we have two angles which are both equal to the same angle DAC, which means that are equal to each other, which means that the angle BAD is equal to the angle ACE. Now also because AD is parallel to CE, we know that the angle BAD is equal to the angle AEC. Also by proposition 129, a different part of it, because these are corresponding angles, I should actually be writing in what angle is equal to what. Like that. So because AD is parallel to EC, we made it that way in the first step. We know by proposition 129 that the corresponding angles BAD and AEC are going to be equal to each other. But we know that the angle ECA is equal to the angle BAD. We had shown that in the previous step, which means, again, we have two angles which are equal to the same angle BAD, which means they are equal to each other, which means that the angle ACE is equal to the angle AEC. Which means that in the triangle ACE, we have two angles which are equal to each other, which means that by 1/6, the sides subtending them are going to be equal to each other, which means that AC is equal to AE. Now again, because we know AD is parallel to EC, we know that BA is to AE, just as BD is to DC. That's proposition 6.2. That if in a triangle you have a straight line parallel to the base, it's going to cut the remaining sides proportionately. So because AD is parallel to EC within the triangle BEC, we know that BA is going to be to AE just as BD is to DC, which means that because AC is equal to AE, we can likewise say that BA is also to AC just as BD is to DC, and this is what we wanted to prove. Given that the angle BAC is bisected by the straight line AD, we wanted to prove that BA is to AC just as BD is to DC, and we have just proven that, which means we are done with the first part of the proposition. And to move on to the second, the converse part of it, having been given that BD is to DC just as BA is to AC, we're going to preserve the same construction. Because AD, again, is parallel to EC, we made it that way. We also again know that BA is to AE just as BD is to DC. But we know that BA is to AC just as BD is to DC, which means we have two ratios which are the same with the same ratio, which means by proposition 5.11 they are the same with one another, so that BA is to AE just as BA is to AC. Now this means because BA is to AE just as BA again is to AC, by proposition 5.9, if the same have the same ratio to two different magnitudes, then the two different magnitudes are equal to each other, which means that AC is equal to AE, which means by proposition 1.5 we have an isosceles triangle here. The triangle ACE is isosceles, which means that the angle ACE is equal to the angle AEC. Now again, by various uses of proposition 129, because AD is parallel to EC, we know that the angle BAD is equal to its corresponding angle AEC, and we also know that the angle DAC is equal to its alternate angle ACE, which means by common notion 1, we know that the angle, or we can say that the angle BAD is equal to the angle DAC, which means that the angle BAC is bisected by the straight line AD. And this is again what we wanted to prove. Given that BD is to DC just as BA is to AC, we wanted to prove that the straight line AD bisects the angle BAC. And we have just proven that, which means we are done with this final part of the proposition, and having proven both the first and last part of the proposition, we are done with it, therefore, etc. QED. That's all I've got to say about this proposition, so I'll end the video here and move on to 6.4.